Hey, hello, look, here we are. It's me, John Park, and this is Show and Tell. I'm your guest host this week. Surprise, I'm not Phil and Lamore. I'm me and Lars. And we've got a bunch of people from Adafruit here to show some cool stuff, cool projects. If you would like to come on with your project, head on over to our Discord. There's a link there. I think you can also go to our blog and work it out from there. But the Discord's the place to be. So head on over to adafruit.it/Discord and look for the show and the link rather to the Discord. Go look for the live broadcast chat channel there. And once you're there, you will see a link to this very StreamYard show and tell. Phew, that was a lot. So to save me, here comes Scott. Scott, what is going on?
Hi, John. Thanks for hosting and having me.
You bet.
As folks know, I've been working on Zephyr, which is CircuitPython on Zephyr. Zephyr is a real-time operating system. And what I've been doing here is I've been trying to get the continuous integration working. So every time we do a commit to CircuitPython, we build all of the boards that we think are impacted, and we actually upload all of those builds to S3. So if you've ever done like absolute newest, that's kind of what you're getting is, and we also use this infrastructure to do like release builds as well. So I've been getting Zephyr running, or trying to get my Zephyr code building in the GitHub Actions. And it's actually, this is the latest build I was just trying. I'm also doing a Windows version because Lady Ada came yesterday and was like, hey, I want to get this going on my machine. And she's on Windows and I'm on Linux, and didn't quite work. So instead of me having Windows here, I was like, you know what, I'll just make a GitHub Actions job that uses Windows that can verify that it's buildable in Windows.
Clever.
So it's spinning. I'm not sure. Yeah, it's still setting up Zephyr. Should be done in just a moment. And then these other ones are passing. So these two build boards on Linux on GitHub Actions, if they have been working. It's the Windows one that I'm trying to get going right now. It's making progress.
Yay.
I will head out after that. But this is really good because this is a prerequisite for getting us merged into the main repository. So once we have this going, we should be able to do those automated releases through S3 and the actual tagged releases as well automatically for boards that are now going to be supported with the Zephyr port.
What's the rough number of boards that's supported on at this point that you're running it through?
Well, right now I only have it set up on 2. So this is a Renaissance RA8 board, which is this like large board from Renaissance. It's like a 480 megahertz processor, and it's got like tons of, it has SD-RAM and stuff too. So this one's kind of interesting. Zephyr supports on the order of like 300 or 400-ish boards total. And in theory, it's relatively easy to just build it for one of those and get kind of like sane defaults for CircuitPython on top of it. But we're only going to target a few, especially those that we don't have support for yet. So these two, I have an NRF one that does Wi-Fi. So Nordic doesn't have an all-in-one chip, but they have a companion Wi-Fi chip. So we don't currently support that in CircuitPython, so I'm kind of targeting newer Nordic stuff with this as well.
Got it.
I got Wi-Fi scanning working on this chip, so yeah. So I'm gonna pick an assortment of it. I've also got like an Espressif dev kit that has Ethernet, so it's an ESP32 using Ethernet from there. We don't really have Ethernet support in CircuitPython, at least natively. So that's interesting too, and
yeah,
hopefully that shouldn't be too hard with Zephyr. Fingers crossed.
Yeah, you don't think of Ethernet when you think of ESP32.
Yeah, you don't.
Think of Wi-Fi and all that.
Wi-Fi should work too. I think like Espressif has put a lot of work into getting Wi-Fi working in Zephyr too. So the goal with all the Zephyr work is that eventually we can move pretty much everything over to this Zephyr port, and then we can do cooler things about managing concurrency and stuff under the hood. So
it's building away. Thanks, Scott.
it's cruising away. Folks can follow along on my Zephyr branch. So github.com/tanut/CircuitPython, and then hit branches and hit Zephyr, and you can see all of the output there if you like.
Excellent. So, well, thank you so much.
Thank you.
Appreciate it. Take care, Scott.
Bye.
All right. Next up, we've got Maker Melissa coming on the scene. Melissa.
Hi. So I got I got this little car here and that I built. It's actually running CircuitPython, but I'm gonna turn it on here. There. Okay, got it. There. So then I got this PS4 controller here, and I can use it to connect to the board, to the car, and I can now control it. It has mechanical wheels on it, so I can go sideways and any direction I want.
That's cool. Oh, the cat backed up. I can tell. we saw a cat tail. Your cat's tail was in the camera view.
Yeah, exactly. He got startled by it. But yeah,
that's cool. So tell me, what's this running?
This has CircuitPython on the board. It's I'm trying to remember the name of the on the airlift I have some firmware called BluePad 32, and that's what allows me to connect to the PlayStation 4
that's
control.
cool.
And otherwise it's not modified at all, hardware. And it has the Feather M4 for the main processor and a little motor controller for controlling 4 DC motors.
That's cool. And there's got to be a sophisticated control scheme for dealing with the mecanum wheels being able to do weird sideways stuff, right? Did you write?
Actually, what I did is I started by figuring out what I needed to go front and back.
Mm-hmm.
And then I came up with another scheme to control the side to side, and then I just mixed them together for just getting it to do any direction I wanted.
That's
and
neat.
Then I'm just using the little sticks on here. It's the only thing I have programmed on there, and I'm just using that to go whichever way I want. But it's not very, it's not very sophisticated at all. It's just kind of mixing the values of what I wanted it to do.
Nicely done. Well, thanks for bringing that on, Melissa.
Thank you.
Take care. Cool car. All right, next up, we've got Jepler.
Hello, good evening. So I want a remote controlled car now, but I'm here to show you what I've been working on. I'm continuing to work on the Raspberry Pi 5 stuff. And so today I've got one of those encoder wheels, and these work, there's power ground and 2 data signals. And when you rotate the wheel, the computer has the job of counting up what you do. And so I've been spinning this while I'm bored. There's a mark here at 0, and every time I go around, it's going to go up by 100.
Oh wow!
Even if the Python program isn't keeping up with each individual count. Here there's 19 counts, 38 counts, 20 counts, and so it's really reliable. And it's using the PIO peripheral that's in the RP1 IO coprocessor, which I think is maybe this little boy here.
Okay.
So this is the second thing that you can do with a little Python module that I've created called RP1 PIO. So on the RP2040, we've got the RP2 PIO, and we've done a lot of cool things with it. And this is bringing that same code, because you could run this code on CircuitPython as well, bring it over to the Raspberry Pi 5, because there's like this parallel mostly the same chip, the RP1. I mean, the RP1 does a bunch of other stuff, but we can run the PIO programs on it. So that library is now released on PyPI, and kind of the 2 proof of concepts are to do the encoder and to do NeoPixels. And there's a lot of stuff that CircuitPython does that it doesn't do yet. We'd love for people to come along and say, I want to do task X, I need feature Y, and come and do that, and put in a pull request. But that's what's up with me, and that is going to kind of wrap up my work on Pi 5 for right now.
Yeah. Question on that, is the PIO accessible on a fixed set of GPIO pins on the Pi 5, or can you assign a pin to
you can assign the pins, so it can use any of it's 27 or 28 pins that are on the standard 40 pin header. For the quadrature encoder, you have to use 2 that are numerically adjacent, so I think I'm using 17 and 18. I just picked them by looking at the pinout. And of course, if it's used by I2C, I don't know if you can use that with PIO, but one of the other things that I did, I don't see where it is here on my desk. We did the RGB matrix bonnet and hat, and that uses a bunch of pins, and they all worked. So my base impression is you can use any of the pins, just so long as you don't need it for a different special function. But yeah, a lot of cool stuff that you can do with Pi 5 now and Python. So check that out. We've got
that's great. Thanks for doing
NeoPixels and RGB matrices and encoder wheels and all sorts of fun stuff.
Yeah. Oh, it's really cool. Thank you so much, Jepler.
All right. Thanks. See you around.
Take care. All right. Next up, we've got Noe.
Hey, what's up, John?
Hey, how are you?
Hey, we are making things spin. We've been making things spin for a couple months now. We're just going to keep the trend going. So this is a motorized turntable. I wanted to put this together for a while now. And with the TMC 2209, we can do that when, that's what we got. So the guts of this is a KB2040. That's the dev board. And then, of course, the TMC 2209 is the new stepper motor that's really silent. And then for the controls, we have, why is this? It's a little grayed out there. It was blurry for some reason.
Yeah, I saw it.
Isn't that weird?
I don't understand
clear.
What it's doing.
I'm using the iPhone, so maybe it's that.
It cleared it up. Yeah.
Yeah. So it's a collab project, of course. Liz Clark put together the code. So it's got an OLED and a rotary encoder, and you can switch between the different menus. So you can turn it on and off, and then you can change the direction. We got clockwise and counterclockwise. And then, of course, we have speed, so you can adjust the speed. So right now it's slow. You go medium, you go fast, and then you can keep rotating it. And the little icons update, which is nice.
Nice.
And then when you go off, it disables the motor, so you can move it, which is nice. Because previously, without the enable pin on the separate driver, it kind of locked the motor in place. So it's nice that you can move it.
Oh, that's good.
Yeah. So really nice. It's kind of an IKEA hack. So we got the turntable Lazy Susan from IKEA. We repurposed the swivel plate and the pretty much just the swivel plate, because I thought I'd 3D print the tabletop, because it's kind of big. It's like a 15-inch solid piece of wood. So I thought I'd print my own out. Yeah. So we did the Learn Guide. It got published today, and we also got a YouTube video that kind of showcases the features.
People should go check out the Learn Guide, because you guys have done such an impressive mechanical setup for the gearing and the connections inside of there. It's
thanks.
Really nice looking build.
Yeah, a little tip. There's a third-party plugin in Fusion 360 called GF Gear Generator, and you just type in how many teeth you want, what pressure angle you want, and the size of the teeth, and it'll just spit out a spur gear and an internal gear, and that's kind of what I use now.
That's what computers are good for, right there.
Yeah, make me a gear, please. Yeah,
no one wants to hand build those things. That's really cool.
Yeah, and this is this week's project. Maybe we'll make some more spinny things with the stepper motors.
Yeah, excellent. And we'll probably see these featured in your videos of other products.
Of course, yeah, totally.
Very cool. Thanks so much, Noe.
Yep, have a good one.
All right, and last up, we've got Tim. Hi, Tim.
Hey, JP. All right.
What are we looking at?
I have been working on the Learn Guide and the examples for the Sparkle Motion, which is a new device. There's actually a mini one as well, but the big one is cool because it has a built-in IR receiver, which is up here. It's a little dark, so you probably can't see it right now, but I've got it set up, and I've been working on the example for it, which is hot off the press. So I have one of these little mini remote controls from the store, and I have it set up to where up and down will control the brightness, although it does overpower my camera here pretty quick, so you can't see too well. And then I have the arrows are set up to cycle through the colors of the rainbow. So just a nice basic demo that shows off the IR receiving. And this one is in CircuitPython. There is an Arduino example that does basically the same thing. And I will mention as well, the Sparkle Motion is actually made primarily for WLED. So that's kind of the primary thing it's for, but it does support Arduino and CircuitPython as well. And so this is one of the examples that we wanted to do with the built-in hardware that's on there. So yeah, check that out in the this is all in the Learn Guide for the big one, which will be live soon. So folks can check it out there if they are interested in the code for this.
So pardon me if you explained this and I missed it, but is it configurable inside of WLED to say, learn what function does what from the random remote you've picked up that happens to...
Yeah, I will say I don't know too much on the WLED side. Erin did all of the WLED pages, so she would be the best one to ask. There is a WLED page for IR, but I don't know too much about it. In the Arduino and the CircuitPython world, there are libraries for both, and you basically get back the codes, and then you, no matter what remote you have, as long as it supports one of the protocols that the library supports, then you'll get back like a numerical code, and you can map that up with whatever remote you want just by going through and pressing the buttons and kind of jotting down what numbers pop out of it.
It's pretty cool. Yeah, I was showing this recently. I don't think I have it in here, but I've got a Game Boy Color or Game Boy Pocket, which had an IR transceiver on it, and there was, weirdly enough, a learning remote app inside of the Mission Impossible game, and so you could, so you could learn remotes from it, but it would be hilarious and absurd to control big LED thing from your Game Boy.
Yeah, I love those games that had some of those little weird one-off stuff in them. That's really cool. I didn't know that about that.
Yeah.
I have one other thing I can show real quick if we're good on time.
We sure are. Yeah.
I made this one a while back. This is totally different. No microcontrollers. This is all on the internet. I'll drop a link. Folks can actually play with this if this kind of thing interests you. But one of my sort of reoccurring hobbies is dabbling in cryptography, mostly really basic or historical stuff, or just stuff that I find kind of silly and amusing, which is what this one fits into that latter category of silly and amusing. So this is, I called it Digramoji, but it's basically a simple substitution cipher. So I can type in some text here like hello show and tell, and then I can click the convert button, and it basically will convert this all into emojis here. And there is a README page which is linked, which explains how all of it works. It's basically pairs. Every pair of letter gets mapped to an emoji, and those pairs of letters are called diagrams, which is where the name Digramoji comes from. And then the same page also works for decoding. So you could actually, I can erase these, and I can kind of take the message that my friend sent me and drop it back in here and get the plain text.
That is excellent.
And then I went kind of one step further, because if everyone uses the exact same emoji mapping that's listed here, then everyone can decode everyone else's message. So there's also a seed right here, which you can randomize if you want, which just plops a random number in there. Which you can see there changes up what the emojis map to. So you can kind of choose your own seed, which makes it map to different emojis. And then when you come back to the page, you have to enter the same seed that it was encoded with in order to get back to
the plain text. So you share the seed with a friend, and now you have a secure emoji cipher.
Yep. Exactly right. Yep. Awesome. And then this one just does plain text here on the web. But the reason I dug this out recently is I actually implemented a Python one that encodes files in this way. So if you've ever wanted your files to be 4 times larger and made entirely of emojis, then I have got you covered.
I appreciate that. That's very cool. Oh, I want to play around with this. So can you drop that link in the chat if that's available for people?
Yep. Excellent. I dropped that in the Discord.
Super. Oh, really great work. That just made my day. Thanks so much, Tim.
Nice. Yep. Thanks. See ya.
Take care. All right, that wraps it up for Show and Tell. Thank you, everyone, so much for bringing on your cool stuff and showing it. Next up, we've got a 10-minute break here while you go and grab a beverage or a snack, and then it's going to be Ask an Engineer. So come on back. Stop by and check that out. Thanks, everyone. If you're just jumped up, bye-bye.